In previous videos, I've shown how to use a process called hydrothermal synthesis to make these sparkly copper particles, copper sulfide nanostructures, and even highly fluorescent carbon quantum dots. In this video, I'm going to be showing you how to make carbon nanofoam with incredible surface area. To start, you're going to need 171 grams of ordinary table sugar. Then you're going to dissolve it in 100 ml of deionized water. This is a very concentrated solution, so there's a very good chance you're going to have to use some heat to get it to dissolve fully. Next, you're going to add naphthalene, about 3 milligrams, and you can find this in old-fashioned mothballs. A warning though, it's going to make your lab smell like old people for a couple of days as soon as you open this. Once everything is dissolved, fill a Teflon hydrothermal reactor with your reaction solution, and then close it up and seal up the reactor. If you don't have a Teflon vessel like I do, you can try using a pipe-fitting reactor, which I showed how to make in a previous video. With everything tightly sealed, place the reactor into an oven at 155 degrees for 5 hours. When it's done, you'll be left with a thick block of carbon foam, which you're going to have to dig out. I used just a popsicle stick to slowly take chunks out, but it was a bit difficult. To begin cleaning the foam, place whatever you can scrape out into a large beaker and fill it with water. Once you've given it a mix and then let it settle, you can see all the unreacted stuff that's left in solution. This can be poured off. To purify it further, add it to a filter and begin pouring deionized water over until it runs clear. After the deionization wash, this is what was left over, a still very wet and chunky powder. So I first let this dry as much as I could, and then when it was mostly dry, I popped it onto the stove to drive off any remaining water. When all was said and done, this is what I was left with, a fairly coarse and dry powder. Now, to get this into a form that's usable for supercapacitors, you can either put it into a blender, or in my case, I'm going to be using a ball mill. So first you place the dry powder into the ball mill chamber, and then I add a whole bunch of steel bearings and shot to help crush up the powder as it rolls. Then the container is placed into the ball mill and it's let to run for many hours. To make sure I had the finest powder possible, I made this little contraption. It's just a regular container with a piece of metal mesh on top, and by shaking it I can get the smallest pieces to come through. And this is the final powder that I've collected. Now I can take this and get it imaged. So I took the powder in to be imaged using a scanning electron microscope, and this is the result. You can see that at the least magnification it has lots of apparent surface area, and looks kind of like little bubbles, and when we zoom in a little bit, that becomes much more apparent. The powder is made of millions and millions of interconnected carbon spheres. Some of them are fused together, some are kind of free-floating. But regardless, these spheres are remarkably round and can be very tiny. Some of them are even less than a micrometer across, so completely in the nanoscale. Now, because of all of this surface area, this powder is an incredible supercapacitor material, or at the very least a good jumping off point to make even better supercapacitor materials. This is only a first attempt though, and I encourage you to experiment and play with the quantities. Try changing the concentration of the sugar, or the amount of naphthalene that you use, or try adding other things to the reaction mixture. I look forward to hearing some of your suggestions in the comments down below. Okay guys, that's all I've got for this video. I hope you've enjoyed. If you have, be sure to subscribe, rate, and comment. If you're interested in more content behind the scenes, more frequent day-to-day stuff, be sure to check out Facebook, Instagram, and Twitter. And if you're interested in some of my research and some other little tidbits, my website is the place for that. All links in the description, and I'll see you next time.